Welcome to our channel. Today we're diving into the cosmos to uncover some mind-blowing facts about stars. Get ready to have your mind blown wide open as we explore the fascinating world of celestial objects that light up our night sky. From their birth in stellar nurseries to their explosive deaths, we'll journey through the universe uncovering the secrets of these luminous giants. Stay tuned. Ever wondered where stars come from? They aren't just sprinkled across the cosmos randomly, you know. Stars are born in nebulae, which are like giant clouds of gas and dust scattered throughout the universe. Imagine a cosmic kitchen with ingredients like hydrogen and helium just floating around. Over time, gravity starts to pull these ingredients together, clumping them closer and closer. As these clumps grow larger and denser, the pressure inside increases, causing the core to heat up, and when the core gets hot enough, boom! Nuclear fusion ignites and a star is born. Looking up at the night sky, it's easy to feel incredibly small and insignificant. But hey, at least we're not alone in the universe. Our closest star other than the Sun is Proxima Centauri, a red dwarf star located just a stone's throw away. Cosmically speaking, of course, it's about 4.24 light years away, which means the light we see from it today left the star over 4 years ago. That's pretty mind-boggling, isn't it? To think that we're seeing light that's been traveling through space for years just to reach our eyes, and who knows, maybe one day we'll develop the technology to travel to Proxima Centauri and see it up close. Wouldn't that be something? Stars aren't just twinkling points of light, they come in a dazzling array of colors, each color revealing secrets about the star's temperature. Think of it like a cosmic mood ring. Blue stars are the hottest, burning with an intense energy that would make even the sun jealous. Moving down the spectrum, we encounter white stars, then yellow stars like our sun, followed by orange stars. And finally, we have the coolest stars of all, red stars. These stars are like the elders of the cosmos, radiating a gentle warmth as they slowly approach the end of their lives. It's amazing how much we can learn about a star just by observing its color, isn't it? Chapter 4. Our Sun, a stellar superstar. We often take our sun for granted, but it's a pretty amazing star, you know. It's the reason we have life on Earth, providing the energy needed for plants to grow and for us to thrive. It's a giant ball of hot gas that's been keeping us warm and providing us with light for billions of years. The Sun's surface is a roiling sea of plasma, with temperatures reaching up to 5,500 degrees Celsius. But did you know that the Sun is actually a medium-sized star? In the vast expanse of the universe, there are stars much larger and much smaller than our Sun. That's right, in the grand scheme of things, it's not even that big. Some stars, known as supergiants, can be over 1,000 times larger in diameter than our Sun. It's classified as a G-type main sequence star, also known as a yellow dwarf. This classification means it is in the prime of its life, steadily burning hydrogen into helium. Don't let the name fool you, though, it's still pretty massive. About 333,000 times the mass of Earth, its gravitational pull keeps our entire solar system in check, and it's constantly undergoing nuclear fusion in its core, converting hydrogen into helium and releasing an enormous amount of energy in the process. This energy travels through space and reaches us as sunlight. So next time you feel the warmth of the sun on your skin, take a moment to appreciate the incredible power of this stellar superstar. It's not just a source of light and heat, it's the very reason we are here today, a true marvel of the cosmos. Chapter 5. Supernovae, the explosive death of stars. In this chapter, we delve into the dramatic and awe-inspiring end of a star's life. Stars may seem eternal, but they have lifespans just like us. They are born, they live, and eventually they die. The life cycle of a star is a fascinating journey through time and space. And when some stars reach the end of their lives, they go out with a bang, a supernova. This cataclysmic event marks the spectacular death of a massive star. These are some of the most powerful explosions in the universe, releasing more energy in a few seconds than our sun will emit in its entire lifetime. The sheer magnitude of a supernova is almost beyond comprehension. Imagine a star suddenly brightening to billions of times its normal luminosity, outshining entire galaxies for weeks or even months. That's a supernova. This incredible burst of light and energy can be seen across vast distances in space. These cosmic fireworks are not only spectacular to witness, but they also play a crucial role in the evolution of the universe. They are nature's way of recycling, spreading essential elements far and wide. They scatter heavy elements forged in the star's core throughout space, seeding the cosmos with the building blocks of planets, life, and even you and me. Without supernovae, the universe as we know it would be a very different place, lacking the rich diversity of elements that make up everything around us. Chapter 6. Neutron stars, cosmic lighthouses. After a supernova explosion, the leftover core of the star can collapse under its own gravity, squeezing the matter into an incredibly dense object called a neutron star. These bizarre objects are mind-bogglingly compact, with a mass about 1.4 times that of the Sun, crammed into a sphere only about 20 kilometers in diameter. To put that in perspective, that's like squeezing all the mass of Mount Everest into a teaspoon. Neutron stars are also incredibly hot, with surface temperatures reaching millions of degrees Celsius. And if that's not extreme enough, they also spin rapidly, some rotating hundreds of times per second. This rapid rotation, combined with their strong magnetic fields, causes them to emit beams of radiation that sweep across space like cosmic lighthouses. Chapter 7. Scuti, the reigning stellar giant. We've talked about medium-sized stars and incredibly dense stars, but what about the largest stars in the universe? Enter Scuti, the reigning champion of stellar giants. This red supergiant is so large that if you were to replace our Sun with it, its surface would extend beyond the orbit of Jupiter. Just try to wrap your head around that for a second. Its radius is more than 1,700 times that of the Sun, and it could fit over 6 quadrillion Earths inside it. That's 6 followed by 15 zeros. It's truly mind-boggling to think about the sheer scale of the universe and the incredible objects it contains. Chapter 8. Stellar Dance Binary Star Systems. Stars aren't always solitary wanderers in the cosmos. In fact, binary star systems, where 2 stars orbit each other in a celestial dance, are quite common. Imagine 2 stars, locked in a gravitational embrace, waltzing around their common center of mass. These stellar pairs can come in a variety of configurations, with some orbiting each other closely and others separated by vast distances. Some binary systems even contain stars of different colors and sizes, creating a stunning visual contrast. It's a reminder that the universe is a dynamic and ever-changing place full of wonder and beauty. Chapter 9. From Cradle to Grave. The life cycles of stars. Stars, like living organisms, go through a fascinating life cycle from birth to death. This journey is both awe-inspiring and complex, revealing the dynamic processes that govern our universe. It all begins in stellar nurseries, where vast clouds of gas and dust collapse under gravity to form protostars. These regions are often illuminated by the light of young stars, creating breathtaking cosmic vistas. As these protostars gather mass, their cores heat up significantly, eventually reaching temperatures high enough to ignite nuclear fusion. This marks their entry into the main sequence, the longest and most stable stage of a star's life. During the main sequence stage, stars fuse hydrogen into helium in their cores, releasing a tremendous amount of energy that makes them shine brightly. This process can last for millions to billions of years, depending on the star's mass. As they age, stars evolve and expand, eventually becoming red giants or supergiants. This transformation is marked by a dramatic increase in size and a change in color as the outer layers of the star cool and expand. The ultimate fate of a star is determined by its mass. This critical factor dictates whether a star will end its life quietly or in a spectacular explosion. Smaller stars, like our Sun, will eventually shed their outer layers, forming beautiful planetary nebulae. Their cores will contract into white dwarfs, which will slowly cool and fade over time. Massive stars, on the other hand, meet a more explosive end. They go supernova, a cataclysmic explosion that can outshine entire galaxies. The remnants of these explosions can form incredibly dense neutron stars or even black holes, regions of space where gravity is so strong that not even light can escape. Chapter 10. Black Holes, Cosmic Vacuum Cleaners. Black holes are some of the most mysterious and fascinating objects in the universe. They are regions of space-time where gravity is so strong that nothing, not even light, can escape their grasp. These cosmic vacuum cleaners form from the remnants of massive stars that have gone supernova. Imagine a place where the fabric of space-time is so warped that it creates a bottomless pit, a singularity where the laws of physics as we know them break down. Black holes are invisible to telescopes, but their presence can be inferred by their effects on surrounding matter. As gas and dust spiral into a black hole, they heat up to millions of degrees, emitting intense radiation that can be detected by astronomers. Thanks for watching. If you enjoyed learning about stars, don't forget to like, subscribe, and hit the bell icon for more cosmic content. The universe is full of incredible wonders just waiting to be discovered. So keep exploring and never stop asking questions. See you next time.